are now in section 12.3, geometric sequences. So this is another special type of sequence, but it's not arithmetic, it is different than that. So let's take a look. What is the next number in the sequence? We have 4, 8, 16, 32. Take a look, think about what the next value is. You can pause if you want. We can see that as we go from one value to the next value in the sequence, we're going to be multiplying by 2. So the next value would be 64. Taking a look at B, again, you can pause if you'd like and see if you can get the next value in the sequence on your own. We can see that as we are going along here, we're going from 12 to 6 to 3 to 3 halves. What's happening each time is another multiplication. In this case, the values are getting smaller, so we're multiplying by a fraction multiplied by a half. And so 3 halves times a 1/2 will give us the next value in the sequence, which is 3/4. So this is a special type of sequence. Every time we're going from one value to the next value, we are going to multiply by the same number. And this is what's called a geometric sequence. And as you can see, each term is found by multiplying the previous term by some number. And that number is a constant. So in this case, the sequence a sub n is r times a sub n minus 1, meaning that the next value is found by multiplying the previous term by this constant r. R is called the common ratio. Here is an important note. If you are ever asked to find r, you can do so. You just need to take one term of the sequence and divide it by the previous term of the sequence. And that, of course, has to do with the fact that you can see what I have here. If I divide both sides by a sub n minus 1, we have it solved for r. So that's why that works. And the sequence that we have here is just a times r squared, a times r cubed, and so on. So that's the pattern here of a geometric sequence. It just keeps going on like that. So write the first 4 terms of the geometric sequence. It gives us an a sub 1. Notice that your a sub 1 is just your a. And that will be, in this case, 27. You are also told that r is 1/3. So it's not too surprising if we want the next 3 terms to get the first 4. We'll just use that previous term. So a sub 2 will take a sub 1, our a times 1/3. And so there's our second term. Now we'll take that second term, multiply it by 1/3. Again, you can pause if you want to get these on your own. And here we are, and there. So the first 4 terms of this sequence are 27, 9, 3, 1. And of course that does continue. We just found the first 4 terms like we were asked. Okay, now thinking about another way to write a sub n. So right now we have that a sub n is r times a sub n minus 1. If we were to start with a sub 1, that is just a, remember that. So a sub 2 is just that a times r. A sub 3 is just a sub 2 times r, which is a times r times another r, or a r squared. So I've kind of already written this above. This is just having it written out here to get that general form. So a sub 4, we will take a sub 3. I think you can see what's happening here. Multiplying it by another r is going to give us a r cubed. Try to see the pattern here. And then I'll do a to the 5th. And a to the 5th, of course, is just our a to the 4th times one more r. So we have a times r to the 4th. So key thing here. So if we want to think about another way to write a sub n, and this would be the more general form so that you don't need to always think about that previous term, notice the exponent on the r and then the subscript of whatever a we're trying to find. So a sub 3 has an exponent on the r of 2, a sub 4 has an exponent on the r of 3, and a sub 5 has an exponent on the r of 4. So we can see that it's one less than whatever we're trying to find. So if we wanted to write a general form, we would say a times r to the whatever our value is, but we would need to subtract 1. So that's another way to find your a sub n, which again makes things not need that previous n, a to the n minus a sub n minus 1, that previous term. We don't need it now. So this is just the nth term of a geometric sequence. Nth term. And we'll see what that looks like. So if a geometric sequence has a sub 1 equaling 3 and r equals 2, find a sub 6. So remember, if you're given a sub 1, that is your a, and that is super helpful. That's all you need. So great. And then you also have your r, which is 2. So now thinking about a sub 6, that is just a times r to the 6 minus 1. And of course you can do this in one step. I'm just showing you the pieces here. So a sub 6 is a times r to the 5th. And we know a and we know r. So if you want, you can go ahead and plug those in and see what you get for a sub 6. And we have 3 times 2 to the 5th. I'll bring this up here so you can a little more space. And so 2 to the 5th, 2 to the 3rd is 8, to the 4th is 16, to the 5th is 32. So 3 times 32. And so a to the 6th is just 96. So we could have done a sub 1, and then we could have just multiplied by 2, multiplied by 2, multiplied by 2, and so on and so forth until we get a to the 6th. Or we can use this formula here for that nth term and do it that way. And then of course what that does is, you know, when you're asked to find a sub 20 or a sub 30, obviously it becomes a lot more straightforward to do it this way using that nth term formula that we have. Okay, now notice this says if a geometric sequence has a sub 4 equaling 12 and a sub 8 equaling 3/4, find r. Now, first off, you might notice that to go from 12 to 3/4, the numbers are getting smaller. So we should probably assume that r is a fraction because that's the way to multiply by something and have it become smaller. So what we want to think about here is we have our a sub n equaling a times r to the n minus 1. So we're trying to find r. That is our goal here. We're trying to find r. So what actually has to happen here is we need to essentially create two equations of two variables and then solve for what we're looking for. And that's because we really just have this formula right here. This is all we have to use. So let's use it. So we're going to take a sub 4 equaling 12. So that tells us that when, so a sub 4 equals 12. So that tells us when n equals 4, we have this a sub n equaling 12. Okay, so that doesn't tell us too much. But if we put that into this equation here, we have that 12 equals a times r to the 4 minus 1. So I'm putting an n, and then my a sub n is 12. So 12 equals ar cubed. Okay, now the reason that that helps us is because I can solve it for a. So a equals 12 over r cubed. But like I said, this is one equation here, but notice it has two variables. If we want to solve for a variable, which we do, we want to solve for r, we need two variables, two equations. So the second thing, I'm going to do the same exact thing with a sub 8 equaling 3/4. If I put that into my one formula that I have, 3/4 has to equal a times r to the n. In this case, n is 8. N equals 8, so n minus 1. So I have 3/4 equals a times r to the 7th. And then I'm going to do the same thing. So r equals 3 and then divided by, I'm dividing by r to the 7th, so 4r to the 7th. And now what I need to do, so big idea here is we have two things that are solved for a. A has to equal this, and a has to equal this. And so therefore, they must equal each other, meaning that I can, the fact that we have a equal and a equal means that now I can do that 12 over r cubed must equal 3 over 4r to the 7th. That's the idea. So a few different ways. I'm going to cross multiply since that is something that's valid and rids me of all of my fractions at least. And then we can divide both sides by 3, which gives us 16r to the 7th equals r cubed. Okay. And now what I'll do is I'm actually going to bring the r cubed to one side. What this does is it allows me to factor out an r to the 3rd. Let's see what I'm left with here. I can factor out an r to the 3rd, and I'm left with 16r to the 4th minus 1. Now the reason I do that is because I can now use the zero product property to say either r cubed equals 0 or 16r to the 4th minus 1 equals 0. But this just tells me that r is a possibility for 0. But we know that that's not the case, because if we just multiply everything by 0, then there's nothing. So, so r equaling 0 is not an option. And then we can solve over here. So 16r to the 4th equals 1, or r to the 4th equals 1 over 16. Now, if we take the 4th root of each side, the 4th root of 1 is 1. The 4th root of 16 is 2. However, we could have a positive or a negative. So when I take the square root, when I take the 4th root, if I were to take a 6th root, I need to consider plus or minus because those are even exponents and you're taking the radical of that even exponent. So I'll put in parentheses here in case you're like, what did she just do? 4th root here. So our r is plus or minus 1/2. And I can write that up here. R equals plus or minus 1/2. Now, if you're wondering why it could be plus or minus 1/2 for the r, let me just show you down here if you are interested. But if a to the 4th is 12 and our r is a negative 1/2, then a to the 5th will be a negative 6. A to the 6th will be a positive 3. A to the 7th will be a negative 3/2. And the a to the 8th will be a positive 3/4. So I'm just multiplying the previous term by negative 1/2. If instead r is 1/2, the only difference that you might be able to see pretty quickly is just that everything stays positive. It doesn't alternate between positive and negative. So the point here is just to show you that you could have either option as your r for what we were given in the problem.